have a new project. This is our new project. We have discrete components. This is the power LED, the output LED, some resistors, capacitor, jumper wires, and this breadboard. This is called LED fader. We're going to use this power bank to test the circuit. Oh, we have the figure 1 Twin Tee Oscillator LED fader. We are using 2 transistors. So that is the transistor we are using. And then the output LED, power LED blue. And some discrete components. So here this is already a module type. This one. Our supply is 5 volts. Power LED. Using 2 transistors, we can able to fade in, fade out, or we are creating an LED fader. This one. And the use of transistor here is as a driver to the LED fader. And then the fader is caused by the Twin Tee Oscillator. And this is the Twin Tee. Twin means 2. 1 T is this. This one is for the first T, and the second T is this. So this one is a high pass filter composed of 2 capacitor and 1 resistor. It looks like a letter T. That's why it's called the T oscillator. The other T is this 4.7K resistor with capacitor grounded. Why is it that I'm using 2 capacitors here? Because I'm controlling the fading of the LED. So with the use of this Twin Tee 2T, which is the high pass and the low pass filter, causing the circuit to oscillate. That's why it's called oscillator. And it is 180 degrees phase shift angle. 180 degrees. 180 degrees from the output, and then the other to the 180 degrees to the filter, and then another 180 degrees to the amplifier transistor itself, which is I'm using 547 transistor. So it will have a 360 degrees phase shift, total of 360 degrees. So it's oscillate, and the moment it oscillates, why is it fading? Why is it that the LED is fading, or we have this LED fader? Because we are creating a sinusoidal waveform. When we are going to connect an oscilloscope here, collector, using an oscilloscope to the ground, let us say to the ground, we are getting a sinusoidal or sine waveform, just like this. So this is the reference line. We have the on and off of the waveform.